Okay, Jan, you want to kick us off?
Sure. Hey, everybody. Welcome to a webinar. Today, we wanted to talk about production Kubernetes, what it means, and some pitfalls we've both experienced and are aware of that people get into before they go live. So my name is Jonathan. I'm a solutions engineer at ShuttleOps. I work on the services side, and I've experienced both as an internal engineer and working with clients, both on non-Kubernetes configurations and Kubernetes configurations. And I basically just help organizations achieve their DevOps needs running on different stacks. And this is my coworker, Greg.
Hi, I'm Greg. I also work at Shuttle Ops, but I actually focus on products. So a lot of what I do is taking what Jan and other members of the services team learn in the field and build it into like a cohesive product so that you guys can leverage it and not have to go through some of the pain that they've experienced in the field. So we're just going to start off with a brief introduction of what ShuttleOps is and what we do, how we can help you, and then we'll get into the presentation and the demo. So there are like really two ways that we can help you with Kubernetes and avoiding pitfalls, also just like with any project, and that's through services. We have a team of solutions architects, project managers, and DevOps specialists that are ready to help you with any size project. We've worked with like small, medium, and Fortune 500 level companies. So we're ready to help you with like custom like bespoke solutions. We also have a product, and this product is a continuous deployment tool for Kubernetes. The product's really focused on giving you YAML-free deployments and allowing you to build workflows that match your business. So like approval-based workflows, and also just allowing you to build pipelines without having to define them as code. And currently, we are offering free onboarding to this product. So if you already have a cluster running with some applications and you would like to use our tool and migrate to it, we can offer free services to help you do that. Okay, so this is just a brief overview of what we're going to talk about today. So the first thing we want to do is, because we're talking about production Kubernetes, we want to talk about like how is that different from a cluster that I just created through the Amazon UI. So like what does production ready mean? We also want to talk about some of the pitfalls that we've seen in the field. So especially around configuration management, observability, and cluster security. And then Jan's going to go into a demo where we sort of pull this together. So what does production ready mean? So it really depends on what your organization is and what it does. So in my example there, you have like Boeing and Petco. Production ready is very different for those two companies, obviously. So it does depend on your organization. And some of these things may not apply to you because you don't care about them, frankly, or some of them may not go far enough. But for like the purpose of this webinar, we'll say that production ready is a system which is secure and sized appropriately to serve the clients. So it's secured and it's big enough to handle the amount of traffic you expect. The ability to quickly mitigate common system failures and be proactive in preventing them. So from like a security aspect, configuration aspect, or more common things like ran out of RAM or disk space or things like that. And then also the ability to make changes to the system in an automated and audible way. So using like best practices around configuration management so that you know who changed the system, when it was reviewed, and you're not afraid to make changes to the system because it's all done in the proper way. So Jan, maybe we'll have you go through the configuration management section.
Sure. So when we refer to configuration management in the context of Kubernetes, we're referring to two things. One is the underlying configuration of the cluster itself, and two is the configuration of what you're deploying to it. So even if you're using a managed Kubernetes cluster from one of the big three cloud providers, from if you're using EKS from Amazon, AKS from Azure, or GKA from Google, you still need to manage a lot of configurations, any features that are enabled. And so that's the infrastructure level of the configuration management. And then there's the application level. If you're, as a DevOps engineer in your company, you're going to want to deploy your application's product to production, right? But there's also other tools that you're going to be deploying to the Kubernetes cluster that will help you get logs and get time series metrics. So we refer to that as well when we talk about infrastructure as code. And without a sane way of managing your configurations, you're going to run into drift, and it's going to become more difficult to deploy your application. It's going to be more difficult to change those tools, and you're eventually just going to lead into a situation where you're deploying less frequently as a result. So we already talked about infrastructure as code and what that actually refers to. But the value of infrastructure as code is that you're actually able to version it into like a Git repository and go through code reviews, do any CI testing, linting, things like that on that repository. And this also inherently makes it easier to extend your existing configurations to new environment. And tools such as Helm actually inherently allow you to just plug in a different set of values for an existing template so that QA and prod are different than dev. CI/CD, I alluded to CI for your configuration management tools. So being able to treat your configuration management as an artifact. But it also doubles as a history of events. So you can see every time that your container built. And the last thing is GitOps. So GitOps is essentially just the concept where everything that you have in your Git repository is also the source of truth. So if I have my Helm configurations for my applications, but they're just stored on my laptop, it doesn't really mean anything because somebody may edit the resources on the Kubernetes cluster directly, and then my configuration has drifted. But if I have, if I'm treating infrastructure as code, exactly as I would code, and I have CI/CD, and I have everything in a repository as a source of truth, I'm able to see exactly what's on my cluster, and I'm also able to roll back easily if there's anything going wrong with configurations being applied. Common tools that I've mentioned or alluded to are Terraform and Helm. Terraform specifically for example, deploying to an EKS cluster on Amazon in an infrastructure as code configuration, which we'll see in our demo, and Helm. So actually being able to package our Kubernetes manifests and being able to template them. GitHub Actions are what we're going to be using for our CI. So we're actually going to be using GitHub Actions to build our application as a container and also package our Helm configurations and for that container and publish them. And Argo CD is a CD tool for Kubernetes, and it allows you to set up Helm charts that you want to deploy. And it also has a GitOps feature, meaning that it could synchronize with a Git repository where you have manifests, and every time you push to master there, it synchronizes the cluster so that there's no drift between what's in the cluster and what's in the Git repository / configuration management solution.
So that was pitfall number one. Pitfall number two that we commonly see is a lack of observability, or sometimes incomplete observability solution. So observability provides insight into the health of the cluster as well as the applications that run on it. And when you do that properly, it allows you to troubleshoot problems at any level. And also it allows you to create alerts for when problems go wrong. And you can build that into like a workflow with, obviously doing like pager duty or something like that, so that you can remediate issues quickly through your alerting. So when we talk about observability on Kubernetes, there are 3 main areas that we'll go into. The first is metrics. So metrics are really just measurements of your application, of your infrastructure, that give insight into things like performance and uptime. You can also watch for levels of disk usage or CPU usage, and it can really be built like directly into your application as well. So we're going to talk mainly about Prometheus, and Prometheus offers like language libraries for every major language, so that you can instrument metrics within your application and export things that you care about. And then with Prometheus, you can collect those metrics and visualize them quite easily in Grafana. So as I said before, it could be used for triggering alerts, and it can also be used for just troubleshooting in general issues with your application running on the cluster. Another thing that is part of observability is aggregating logs. So what we mean when we say that is collecting logs from different systems and storing them all in one area. So a good example of that is Elasticsearch, where you can collect logs from application, infrastructure layer, and store that all in Elasticsearch, and then run queries to analyze that data, search that data so you can like have a historical record of what happened when. And this obviously is really powerful when you're troubleshooting, and it's really great to create visualizations using Kibana as well to get insight into what's happening. The third is tracing. So tracing is really about visualizing the entire transaction of like a request, for example. So imagine like a client makes a request to the server, and your system is a distributed application made up of microservices. So one HTTP request to your initial server could have like auth modules, and then like a bunch of separate service modules. And you want to actually see the flow of that transaction. And in that context, the transaction is like the entire life cycle of that. And being able to see like which service caused the error, or where things broke down, is a problem that tracing solves. And that really becomes useful when you've adopted like a full microservice architecture. We won't get too much into tracing in this, but there are some tools to help you do that. So for metrics, there is obviously Prometheus and Grafana, which everyone's probably familiar with and really common. Prometheus scrapes and scrapes targets, and you can add new targets dynamically through the Prometheus operator, which provides like a custom resource definition to do that. So you can treat it like any other Kubernetes manifest, and you can do that dynamically, and it really works well with like the ephemeral nature of Kubernetes and pods. And so Prometheus scrapes those targets and creates time series data. And then Grafana is a tool that allows you to query Prometheus and then visualize it. Elasticsearch and Kibana I talked about as well. Elasticsearch is a data store that allows you to search and analyze logs. Kibana is a visualization tool for that. And then we typically like to use FluentD as our log collection tool. So it can collect logs of like the Kubernetes components, like kubelet, of the node itself, or of like your actual application running as well. And then a really common tracing tool that is CNCF graduated is Jaeger. So Jan will talk about cluster security for you.
When it comes to cluster security, it really is two high-level aspects. One is just making sure that all the components that make up the cluster, including the cluster itself, so your how you configure Kubernetes and also how you figure Grafana and Elasticsearch, and is all making use of RBAC. It's all making use of any auditing logs, any auditing trails that you could forward and put in Elasticsearch. You have authentication in front of all of these. For example, with Elasticsearch and Kibana, right outside the box, there is no login page. So anybody in the world can go and log in and start viewing your logs if you have like a public-facing Kibana endpoint. And so that's not good if you have any customer information in your application that's being logged. And the second aspect is also just being able to scan for CVEs on container images, and also to address runtime security in your containers as well. There's a bit of infrastructure security as well, making sure that security groups are in place for your cluster, and that shouldn't be aforementioned, but we're not going to go into too much. For security, there is, again, three levels. The first is just the Kubernetes API. So we refer to it as policies because you can make use of tooling that will actually dictate how the Kubernetes resources can be used, and they can actually prevent certain resources from being applied, and they can actually alert whenever something is complying to the policy. So this is really useful when you are starting to have more teams use your Kubernetes cluster. You're sort of scaling how many people are using it, and you want to make sure that everybody follows best practices. Obviously, not everybody's going to listen, so you're going to start to have to enforce some rules. So if somebody tries to apply a resource that doesn't conform to your policy, it's actually not going to get applied. The service mesh is just looking at the service level in terms of security. So this allows for encrypting traffic between services, introducing authentication. So a service has to prove to another service that it is actually that service that's communicating to it, and also RBAC. So you can actually say that service A can't communicate with service B. And this is useful, again, when you've scaled up and you have many different types of services on the same cluster, some of them not even related to one another, not part of the same product. You probably want to keep those segregated. And the last level is the container level. And again, that includes scanning for CVEs at build time, but you could actually use tools to also look at the runtime security of your container. So any CVEs that are detected during runtime, and also any unexpected behavior for your application. And common tools for that, so Gatekeeper, for example, is a controller that prevents certain resources from being applied if they don't conform to the policy. Istio is a popular service mesh that you can configure to encrypt traffic between services and to set up rules for which service can talk to who. And Falco is a tool that can detect unexpected behaviors of your application inside the container. And Tri-V is a tool that can actually scan your container image and detect any CVEs. So now it's time to show you what we came up with for our demo. So I'm going to share my screen. Oh, so Greg, thanks. We've created a repository that contains, first and foremost, our configuration for the cluster itself. So I'm using Terraform 0.14, and I have created a configuration that creates a VPC on AWS. It also uses a model I created for EKS, so it spins up a Kubernetes cluster on Amazon. There's actually a lot of things involved within this module. For example, any security groups that need to be used for the node, IAM policies for the EKS control plane, IAM policies for the worker nodes, the size of the instances, which subnets they go into. So this is a lot of resources just jam-packed into one module. And I've also created a module for an ECR repository. And this ECR, for anybody who doesn't know, is Elastic Container Registry. So this is Amazon's service for a container registry where you can publish containers to. And then this also has the IAM policies, so you can pull from that container registry, and you can actually schedule the container images on the worker nodes. The second bit of configuration in this repository is, and not only configuration, but also our application code itself. We've created a dummy application of a Golang. It's a Golang-based application that we're going to be running on our Kubernetes cluster. And it's very simple. All it is it has a hello world endpoint. It logs every time we hit this endpoint, and it also collects Prometheus metrics. And the configuration on the application level here is a Helm chart. And honestly, if you just do Helm, if you just use Helm's built-in chart creation tool, this gets you most of the way there. But this creates a templates for the deployment, which manages all these all the pods for this container image, and also the service itself. So we have a Helm chart here, and we also have a CI setup for GitHub Actions. And the CI has two jobs. One is building this container image. So it's also making use of some GitHub Actions specific to ECR. So logging into ECR using AWS credentials, which I've also provisioned here as part of the ECR module. So it makes use of these credentials. It logs into ECR, builds this container image, and then pushes it. And then there's also a CI step for our Helm chart. So this actually makes use of something called the chart releaser action. And what the chart releaser action does is it very transparently just, once you specify the directory of the chart, it'll build it, it'll see if there is a new version that needs to be updated, and then it's going to make use of GitHub Pages and use GitHub Pages as your Helm chart repository. And so what that looks like is you have this CI setup with two jobs. Again, this is the container job that builds and pushes the container, and then the Helm chart job, which packages the Helm chart and publishes it as a release. And if you go to our repository, we actually have 6 releases of our chart. And you can actually see on AWS that we have our ECR repository that was spun up by this Terraform configuration. If we click on this repository, we can see something really cool here, which is a set of our vulnerabilities for our container image. And this is just making use of ECR's container scanning feature. And it just looks at CVEs that are detected on that container. And while a lot of organizations, in my experience, don't treat containers as security vectors to the same degree as a virtual machine, because there's Kubernetes on top of it, and it's managing traffic. So you can't just have attackers directly go to a container necessarily. It's still very good for your security posture as an organization to collect, your CVEs, to track them, and to mitigate some of them. And so that can help you pass SOC 2. It can help you pass PCI DSS. And so that's our CI for both our container for our application and the Helm configuration for it. We also have a bunch of bootstrapping steps for our cluster. So once you spin up the Kubernetes cluster, it's not set up yet, right? You just have a cluster and you haven't even authenticated to it using kubectl yet for the first time. So there's some inputs here, mapping which IAM users can actually interface with the Kubernetes API. So I have an example with 2 users. So I've put, so in the values here, I put Greg and I put myself. And I also put the Route 53 hosted zone. And that's used for something called external DNS. And external DNS allows you to automatically create DNS records for your public-facing services. So for example, here I have a annotation that I'm going to be using for Grafana. And once I set up this host name, and of course mine is going to be a little bit different than grafana.example.com, but once I set that up, it's automatically going to create a record. You can even specify, this is not related to external DNS, but this is related to EKS. You can specify a AWS certificate manager, certificate ARN, and it's actually going to put TLS on that load balancer for this service. So the first thing that we deploy using this setup is Argo CD. Argo CD is going to be our CD tool for all of our Kubernetes resources, and it's also going to serve as our source of truth. So there's some steps on how to do that. But long story short, we've deployed Argo CD. It's facing externally. It's behind authentication. So if I log out, I'll have to log in again. And it's also behind TLS. And as you can see, I've already deployed 6 things here. You already saw the Helm chart for our dummy application. So you can see here we have our dummy application set up. I put some parameters here just to make sure that, as I mentioned, the certificate ARN is being used, and it's of type load balancer. So, I've set this up with our image. So this is our ECR repository being referenced. It's all synced up. The desired state matches the actual state in the cluster. So this is all running. And if we click on our service, we can get a host name. And we can see that our application that we deployed is actually running. And when it came to, I think I mentioned that this is instrumented for Prometheus, right? So there's some Prometheus logic here. You can actually go to a /metrics endpoint, and all the Prometheus metrics are ready to be scraped. So that was our first, deployment for. That was the application that we actually, let's say if this wasn't a demo, this would be your product application that you write yourself and you have a CI for, and that you have a Helm chart for. And we also have all of our quality of life, observability, monitoring utilities here. So the second thing we deployed was Elasticsearch. And we also deployed Kibana. And once those were, and so we deployed those actually with specific values just to make sure that encryption is enabled, that the authentication is enabled, because out of the box, as I mentioned, there's no login page. Anybody in the world can see it. So that's all set up. If you go here to Elastic, you'd have to log in, it's behind TLS. So that just shows you how much setup you have to do there. And you get all these logs, right? But there's also a config map that is used by FluentD, which forwards all the logs to Elasticsearch. And that doesn't come in as part of the FluentD Helm chart. we actually set it up as a separate resource here. And this is it seems like a somewhat extensive configuration, but it's actually pretty simple. It just forwards all the logs. It doesn't filter anything out. So you're going to get a lot of noise here. You're going to get logs from your actual utilities themselves. From Elasticsearch itself is actually part of these logs. So it takes a lot of grooming to get Elasticsearch to become that point where you get meaningful dashboards, where you get logs relevant only to your application when you view the particular dashboard. Something interesting about that separate manifest is that here you can see there's a Helm icon next to all of the applications, but here there's a Git icon, and that's because we're not using a Helm chart. This is directly synchronized to our Git repository, so the one we have right here, and it's synced to master. And so every time I push the master, it's going to make sure that it's going to treat that as a desired state, and it's going to make sure that the actual state, i.e. all the resources that we see here, are matching that exactly. So with another push to master, I can just change this config map. So that's what GitOps means. And we also, with that, as I mentioned, logs are already set up. The next thing after that was setting up our monitoring utilities. So this is quite extensive. This actually deploys Prometheus and Grafana, and also a Prometheus operator, which includes custom definitions for, as you can see, Prometheus rule. It's a custom resource, service monitors. So these are additional resources that you would add. For example, for our dummy application, you're going to have to go to the parameters for this Helm chart and add additional service monitors that will match the labels of the application, our dummy application. And then you would actually be able to start scraping and seeing all the time series metrics for our dummy application here. Right now, you can only see the stuff that was automatically set up by that Helm chart. And then from there, once you have that set up, you also need to start building meaningful dashboards, create rules, and then create alerts. You can hook up those alerts to PagerDuty, for example. So there's quite a bit of work just to set all these tools up. And then once you set them all up, then you are able to groom them and get them to where you want them to be. And that's not even to mention some of the other aspects that we talked about. For example, a service mesh. And for example, container runtime security tools such as Falco, or application tracing such as Jaeger. So if I were to add Jaeger, I would have to go back to our dummy application, and I would have to instrument it for application tracing, and then deploy Jaeger and set that up to work with our application. So there's quite a bit of work to get it to that point, but hopefully it demonstrates some of the talking points that we mentioned when we talked about the 3 pitfalls.
Awesome. Thanks for that demo, Jan. So lastly, we just want to open it up to questions. So everything that Jan demoed we'll have available on GitHub. If it's not public right at the second, it will be public as soon as the webinar is done.
It's
so
actually,
if you wanted to take a look at what we've done.
It's already public. You can hit it now.
Public. All right, there you go. You can use it right now. Yeah, so there's a README there where you can see, how you've installed things, all the components, and you can interact with us if you want through that repository to ask questions. You can also ask any questions you have right now. The Q&A button is not showing any questions, but I think we have one here in the chat.
You can check one in the chat.
Thanks. Okay, so for a project just starting now, what would be the single most important thing to concentrate on? Jan, do you want to field that?
Yeah, I was debating between two things. I was debating between monitoring slash logging and configuration management. I'm going to say, from the perspective of security, okay, that kind of narrows our options. But I was just going to say, naturally, I think people do a generally decent job of, for example, using Helm and packaging their application, but they keep Helm locally. So they don't set up a CD tool for Helm. And then they're just going to get the situation where it's going to drift later down the line. So first thing right off the bat, set up Helm. Already, most people do that, but set up a CD tool for Helm. Set up a state of truth Git repository where you can actually make pull requests that affect the desired state. So do that. Ensure that logging and monitoring are set up. From the additional clause there, from the perspective of security that was added to that question, I would say just ensure that you're not using AWS access keys and secret keys directly in environment variables in the deployment configs. Even if you do them as secrets, that's not that good, because the best thing is to set up IAM roles that are assumable via OIDC by service accounts in Kubernetes. And so you'll never worry about credentials. So you could do that. So make sure your IAM policies are set up, and that's specific to AWS, but there are similar analogs for Google, for example. So I would say look at all the security best practices for how you deploy your application.
Yeah, I would say, like, if you're starting from complete scratch and you just created an EKS cluster, for example, the rudimentary, like, most first thing you should do is just make sure that things are, like, nodes are in a private subnet, security group rules are configured properly, so that only certain people can access your control plane for Kubernetes, and just really, like, the basic infrastructure level security would be where I start, and then everything that Jan said for sure is important.
You can also, one thing that I know of that a lot of people forget to do is to enable the audit log in Kubernetes, and that can show you all the create delete operations by different users, and that could be very useful when you're passing like a SOC 2 audit and you have to prove that all of your control planes have everything that has change management involved, like changing anything related to application, is audited. So that's really important, and it's something you could do early on.
So, excuse me, there is another question. So it says, Kubernetes is a challenge. What do I need to consider as I move toward a cloud native Kubernetes deployment? So I think that kind of means that they're deploying not using Kubernetes. They want to move to Kubernetes to, reap those benefits of using Kubernetes. What's something to consider when I'm moving towards that sort of cloud native model?
Do we want to break down what cloud native means to some of the audience?
Yeah, if you want to, like, I've got lots to say. Let's assume you need to containerize your app.
Mm-hmm.
So, like, that's obviously step one for deploying to Kubernetes. But another big thing to consider is just, like, thinking about how your app runs. Can it be replicated easily, or is there a problem with more than one copy of your application running? Like, can it, like, for example, share a session so that you can actually have, like, 3 of your app being load balanced too? That's, like, one thing to consider. Another is, like, how is it configured? Does it need a config file only? or like is it already sort of a 12-factor app where you can use environment variables? So like those like application layer things are something that sometimes is overlooked when you're moving to like a Kubernetes style deployment.
Yeah, and I think the second part of what cloud native means is just being ready to actually interact with all the tools in the ecosystem. That, for example, for application tracing. So if you have a legacy application that has never run on Kubernetes, most likely it's not ready to, or it's not instrumented yet for Prometheus. It's not instrumented yet for application tracing. It might not even be at the point where it's truly service oriented. It might actually be more monolithic. So obviously there's a bigger discussion of what can be done to sort of break it down and to bring new features to other services, and it's a much bigger discussion. But you have to realize that while you want to enable like service mesh features and stuff, it is a long way before you're going to get your application and how it's interacting with other services at the same level as when you look at best practices and we look at how people are using Istio with microservices and all of that. But you have to focus on what you're actually currently missing, what your current pain points are. So for example, if you have errors in production and you're looking at a stack trace and you're sifting through the logs, and the logs are just telling you, okay, it probably happened at that point, then you might actually want to consider instrumenting your application for traceability, for example. I think that's the right mentality to use when you ask yourself, how do I move to cloud native?
Okay, there's another question. If you're a business leader, how would you sell Kubernetes? So maybe I'll start with that one. I think from a business perspective, why Kubernetes is a win is because you can introduce change quicker. It's easier to change your system like without introducing downtime, and you can do it like extensively, like across the entire node. Every pod will be destroyed and recreated with the configuration that you want. You can do it, using like Canary and Blue Green, like more updated deployment methods, and that allows your business to develop features, or at least deploy features quicker, maybe not develop them, which is a huge win for your business. It's also like part of it is you can move some of the knowledge and some of the responsibility of deployment to the developer itself themselves, because really it just becomes Docker files and manifests. So I think that's both something that developers can learn to do, and they have that knowledge of their application. So you can sort of shift the whose responsibility it is to run the app onto the developers, which I think is like would be my preferred way of doing it, because they do have that in-depth knowledge of their application and should be able to fix it when it breaks. Do you have anything you want to add to that, Jan?
No, that was really good. Just the way you summarize, I think just reducing the change fail rates and increasing your ability to have trust in your underlying infrastructure is just inherently going to make deployments more easy, and it's going to allow you to deploy more frequently. So there's another question here from James.
Yeah, I can't actually see it, so yeah, go ahead.
Okay, so from an observationable perspective, if apps run off hours and fail, how do we get a centralized DC informed of the failure for break/fix actions? So there's two things that are being alluded to here. So observability and actually being informed of the failure. And break/fixed actions. And I think that well, obviously the observability is referring to uptime monitoring, right? So if it's a user-facing application, it's an actual service you can hit, you could set up uptime monitoring using Prometheus. There's a tool called Black Box Exporter, for example. You can make sure that you can collect those metrics in a dashboard, create alerts on them, and those alerts can go to PagerDuty, and you could get operators notified that it went down. Now the break/fix actions, I think that might be alluding to something even like a Slack notifications, a Slack notification, and maybe you could set something up. I really don't like this term, but chat ops to like restart the application. Although Kubernetes does that inherently, so I don't know if that'll be the right thing. I haven't explored that too much, but I think that the key here is getting your observability to the point where you understand exactly what component failed, so that the break fix action is just inherently understandable. So on one hand, if you read some of Google's SRE guidelines, they say you need to alert on things that the users care about. Like, I can't hit the site, not that the database isn't working necessarily, because they don't care about the database. But at the same time, you want to make those alerts as actionable as possible. So if I have an alert that I get in Slack, well, I actually have PagerDuty, so I'm woken out of bed, but then I get something in Slack as well, and you can set up Grafana to do both. It'll say, well, this component is failing. So when I'm logging on off hours, I know exactly what component I'm going to be fixing. That's how I interpreted the question. I don't know if that's exactly it. James, if you want, you could.
One thing, yeah, you can definitely clarify. The one thing I wanted to add to that, Jan, was that it sort of sounded like he was alluding to if apps run off hours and fail. So I'm not sure if that means it's like a cron, but if, in that case, like Prometheus is a really good tool to use to monitor those sort of like short-lived jobs, because you can use like the built-in service discovery to make sure you're actually collecting those metrics. And then, yeah, like collecting the metrics, creating alerts around, those failures, and then just tying that into whatever tool you're using for alerting your team, your ops team, like PagerDuty or what have you. Okay, so there is another question. You want to read that one, Jan?
Yeah, so there's two more in the open question. And the first one is there a concept of different environments in the application lifecycle in the Kubernetes world, as in dev, QA, UAT? How does or how can this differ in practice?